let's review complex numbers. So let's say we have quadratic function z squared plus pz plus q equals 0, and one of the roots is given to be z equals 3 plus 4i. Then we are asked to find p and q. So one thing that you must remember is that in quadratic equation, the roots are conjugate of each other. So we know that one of the roots shall be equal to 3 minus 4i. Now, we return to this quadratic function by starting with the roots. So we have c sub 1, okay, you say c minus the root plus 4i, and another one is c minus 3 plus 4i. Now we can regroup this, minus 4i, and then we have z minus 3. This is minus, sorry, let me erase this. Wait, using red. So 3 minus 4i. So this shall be plus 4i. Okay, what's the reason for doing this? It's because we can apply our knowledge in special product on sum and difference, where x minus y or x plus y, x minus y equals x squared minus y squared. So this is simply the same as z minus 3 squared minus 4i squared. Okay, it's equal to 0, by the way. Okay, so we have here z, this is c squared minus 6z plus 9, and this is 4i times 4i is 16i squared, and I squared is negative 1. So times negative, that will give us 16. So we have now z squared minus 6z plus 25. Now we can answer what the value of p and q are. So p is this one, which is negative 6, and q is 25. Okay, there is another way of solving this. If you remember your lesson in junior high school, where the sum of the roots is equal to b, and the product of the roots, okay, product of the roots equals c, where you have the form ax squared plus bx, okay, bx plus c equals 0. This is basically the same as this. So if you don't want to solve it this way, you may just use the knowledge on sum of roots and product of roots. So you have 3 plus 4i plus 3 minus 4i. So that actually gives you 6. That is your b. And wait, this is 6. 3 plus 4i, 3 plus 3 is 6. Yeah, that's 6. But why is the answer here different? Wait, let me go back to this one. Minus 7 minus z. Sorry, the sum of the product is negative b. That's the rule. So negative b, b here is, get the negative of that. So the answer is negative 6. Okay. Actually, it's the negative. The rule is negative b over a. And this is, I think, c over a. Okay, this is the rule here. The other one is c over a. Okay, so let's have c. The product is, for c, we have Let's just put it this way. Over 1. Okay, let me correct my mistake, sorry. So sum of the roots, you consider that b. And to get the sum of the roots is, get the sum of the roots, and then the middle term is negative b over a. So we still have here our b, okay, b equals negative 6. Okay, so for the product, we have 3 plus 4i, 3 minus 4i. Of course, this gives us also 25. Which is 25 over a. Our a is 1. Okay, so either you do this or the other one. Okay, I think this is how we get the middle, negative p of a and c of a. Now let's move to the other one. Okay, so let our w be negative I, z minus 3, where w and c are elements of complex numbers, and we're asked to find w when c equals 4i. So it's very simple, it's just a substitution. So let's do w equals negative I times 4i. So negative I plus 4i, and then minus 3. So this gives us 4, because negative I times I, negative I squared, that becomes positive. So 4 minus 3, we shall have a number equal to 1. So that's our w. Then for the next one, our w equals negative I, then negative 1 plus 3i minus 3. Negative I times negative 1, we have positive 1 plus 3 minus 3. That leads us to 1. Okay, the next question is, it says that z is transformed to w, and then we are asked to describe the transformation. Okay, describe the two kinds or the two types of transformation that happened here. Okay, so let's start with z equals 4i. Where is it? 1, 2, 3. Let's say it's here. Let's use yellow 4. So that's 4i. This is an Argand diagram where this is real and this is imaginary. So we have here 4i. It has been transformed into 1 here. So you can see that it seems that from here, and 4i, it has moved to horizontal axis in this direction. Okay, so this gives you transformation of, wait, let me erase. Okay, transformation of 90 degrees count clockwise. Okay, and then from here it moved 3 steps here, 1, 2, 3. So it appears that the first transformation is a rotation of 90 degrees clockwise. And then second transformation is moving to the left 3. So move 3 steps or 3 units to the left. Okay, so it's just like negative 3, 0. You're moving horizontally 3 to the left. Okay, let's try to work on the next one. Let's see if they have the same transformation. It must be same for both of them because it says we have to describe the two kinds of transformation that happens between these two on these two complex numbers. So negative 1 and 3i is, let's say, here. So let me write in the diagram our complex numbers. So from here, it became just 1. Are they both 1? I, sorry. This is I. Because negative 1 negative is I, sorry. I plus 3 minus 3. So this is I. So it has been transformed into I. So imaginary. Where is that then? Negative 1. Sorry. I'm sorry about this one. My graph is wrong. My mistake. So negative 1 and 3 must be here. Yeah. So let me draw let me draw the okay. Now 3 1. So if it moves 90 degrees, so it shall be higher. So it's just like this. We just reverse it. So negative 1 3. Wait. Okay. Negative 1 and oh, doesn't right. Okay. Let me erase. So we are here have here negative 1 and 3. So the reverse of that is 1 going to the left. Going to the right side, we have 1 and 3 here. Okay. So if you try to work on that, it has moved 90 degrees, but then, so this is the 90 here. So it moved 90 degrees, but this also moved 3 steps from here, from that point. 1, 2, 3. So it now ended here, which is our here, which is I. So this is now done. Okay, so same thing, both of them were transformed 90 degrees clockwise, and then it moved 3 steps to the left. Or you can also make use of this where let me erase this. I don't know if I can still erase this. Okay, we can have also represent our z as r e I theta, and our W, oh, we're not looking for W, C and I, erase, and our I, negative I actually, because that's what we use here, negative I equals e to the negative I pi over 2, that's 90 degrees clockwise. So we can have, let me check if I can move this, okay, and move out. So we shall have, let me write, so our W is equal to negative IZ minus 3. So negative I is e to the negative pi over 2I times z r e I theta, then minus 3. This gives us R E I pi minus pi over 2. So we can have is theta minus pi over 2, then minus 3. So this represents the transformation of 90 degrees clockwise. And the other transformation, negative 3, is moving to the left 3 units. Okay, only horizontal movement. Okay, there's another question to this one. It says, hence or otherwise, let me move this. Uh, hence or otherwise, hence or otherwise, find C. So a while ago, look at the spelling of my Y's. Too much use of C in a complex number. Otherwise, find Z. Okay, when W is equal to 1 minus 3i. Okay, 1 minus 3i. Find Z. So it's the reverse of what we did a while ago. A while ago, we're looking for W given a C. So what can we do here? We know that W is also, remember that W is equal also to I Z minus 3. And this is equal to 1 minus 3i. So we can equate the two W's. 1 minus 3i equals negative IZ minus 3. Then we shall have 4 minus 3i 1 minus 3i, right? Let me erase this. So combining terms together. So 3i, IC, yeah, minus 3 transformed to the other side will become 4. So we shall have 4 minus 3i equals negative IZ. So negative IZ is equal to 4 minus 3i. So our Z is equal to 4 minus 3i over negative I. That's negative I. So you can solve this using conjugate of this one, or dividing, multiplying, and divide, multiplying this by I, so that our denominator will become 1. So, or you can use your GDC, as simple as that. Let's not try to complicate things. It's already a complex number. So we can say that our Z is equal to 4, 4i plus 3, 3 plus 4i. Okay, let me just arrange that in proper order. Use the real number first. So 3 plus 4i. I think given in, if the given is 1 minus 3i, let's try to work on this given, and then let's find the original. Okay, let's say we have, we're just trying to put this here and check if we understand the whole thing. Okay, again, real and imaginary numbers. So the transform C is, what's a transform C again? The given W is 1 minus the given W. 1 minus 3i. So let me write that. 1 minus 3i. So that's going to be here 1 and 3i. 1, 2, 3. Okay, this is a transform. We're looking at its original. So we know it has come from, let's try to work on this. It is the complex number. And it ended with, let me check. I think we're looking for the z. Okay, so it ended up in 3 plus 4i. Plus we're just checking if in the graph we can visualize the meaning of that. So this is actually your z, and this is, let me erase. This one is your w, which is 1 minus 3i. So it says it comes from this side, 3 plus 4i. So it has been moved 3 steps. So doing the opposite. So from here, 1, 2, 3. So it has come from this point. Okay. And then the origin, we return it to the opposite. So it has come from, what is 3 plus 4i? Yeah, 3 plus 4i, sorry. 4. Yeah. This is 90 degrees. So the origin is z. So this is the origin. We're just checking that the answer is correct. The answer is 3 plus 4i. So when it moved here, same clockwise. So it will be here, and then it moved 3 steps. That's why the W here is 1 minus 3i. Okay, so that is just checking on the correctness of the answer. Okay, so we'll stop at this, and I'll try to work on some more problems for you to help you with your review.